The third pillar we'll go through here is monitoring. Really, this pillar is all about understanding how your APIs are performing and operating in production. So we're looking at runtime protection, actually active protection of the APIs, right? Policy enforcement, requiring authentication of users to access endpoints, filtering traffic. Maybe we need a geo filter traffic. We're only expecting traffic from a certain region or IP address and so forth. That's an aspect of real-time runtime protection that you can implement. The next category is threat detection. So how do we analyze the traffic to look for things like fraudulent transactions, fraudulent traffic, distributed attacks? So attacks that are coming from lots of different sources that are targeting similar resource or performing similar functionality. And you want to be alerted to that and make sure you're controlling it properly, as well as incident response. You can capture all the traffic, you can log it all, and you can put it into a repository to then retrace the steps and understand what happened, and then implement the appropriate mitigating controls for future similar attacks. And then you want to validate controls. Make sure that all the controls that you've implemented at the gateway, at the firewall, in the application itself are functioning as designed, that there aren't any surprises happening in production that you aren't expecting, that you're finding any anomalies or unexpected traffic from going unnoticed and without control. Now, there are really two fundamental approaches to runtime monitoring. There's a proactive blocking approach, which you'll find with things like a gateway or a web app firewall. Here's where you can actually enforce policy. You can define in a gateway that these endpoints are only accessible with valid authentication, and they actually performed the authentication. Or with the firewall, maybe you want to implement rate limiting or IP whitelisting or these types of things. And if the traffic doesn't match, it gets blocked. The other side is more of a reactive alerting mode for monitoring. Here you want to probably capture all the traffic, log it, put it into a SIEM or a log management type of solution or a runtime API threat management tool. The issue here is you may not have enough context in order to make judgments about whether the traffic is legitimate or not. So you want to get alerted, you want to be notified, you want to be able to retrace steps, because the last thing you want to do is block legitimate traffic. And there may be instances where there's just simply not enough context to be able to make a yes, no decision on it. So you want to then have that alerting, that monitoring ability to go back and understand the traffic and maybe refine the rules for your more inline proactive technologies. Another aspect of monitoring is to do API discovery, to actually watch what's happening on the wire on your network to identify APIs that are in use and active on your network. This can be useful for generating that inventory, for discovering APIs that were undiscovered, for finding undocumented or unknown APIs or unknown endpoints and the like. But you need to be aware that this is not necessarily going to give you a complete view. If your goal is a comprehensive inventory of all your APIs, which it should be to satisfy those governance requirements, you need to look well beyond this, because APIs may exist within the firewall that are not being seen by your monitoring tool. You want to be scanning code repository to look for these types of APIs or crawling or app testing. But that's how you're going to get a comprehensive view. And ultimately, you want to enforce that all APIs are being managed centrally in something like an API gateway. Then the other limitation of discovery is if you're looking at network-based discovery, it's only going to see what it sees, right? So if there are APIs that exist inside the firewall on network segments that aren't monitored, you're not going to see them. If there are APIs that aren't being exercised or endpoints that aren't being touched, you're not going to see them. So you really want to have a more comprehensive approach to discovery and finding all of your API footprint. The other limitations of monitoring, we talked about it, is the visibility, but it's very appealing to think that you can insert something in line that will magically protect you from all sorts of threats. But the reality is live traffic has very limited context. If you look at, say, the Coinbase example, where user A was trading crypto on behalf of user B, any inline tool is going to see simply an HTTP request that's got a source account, a destination account, an order, some other details. but it's very unlikely that there's going to be knowledge be at the inline tool level to know if that's a legitimate transaction, whether that source account or destination account belongs to the user that is requesting it. That's why we implement authorization at the app level. That's where the context exists to know, is Dan accessing Dan's records or is he accessing Jeff's? And inline tools are great for monitoring, but are very likely to miss a lot of active attacks. So you want to make sure you're actually attack simulating to find where those vulnerabilities are before they go live and to implement the appropriate corrections. The other thing about monitoring is, in many cases, if you're going to implement API monitoring technologies, that may well mean sharing your data with third parties. And that may be a violation of privacy issues, can cause bandwidth concerns, or even latency. So things to be aware of when you're looking at monitoring capabilities.